1 minute to separation.
Apollo 11, this is Houston. Your go for separation. Our system's recommendation is arm both pyro buses, over.
Okay, pyro B coming armed. My intent is to use bottle primary 1 as per the checklist, therefore I just turned day on.
Roger, we concur with the logic.
We're awaiting confirmation of separation.
This is Houston, we copy. Roger.
We confirm the separation here on the ground.
That was secondary propellant on Quad Bravo.
Quad Bravo, yeah. Both the primary and secondary contact Quad Bravo.
Roger, we copy.
He's stand by.
Apollo 11, this is Houston, radio check, over.
The Goldstone station reports a very weak signal. We believe that Mike Collins is now maneuvering the spacecraft in the transposition and docking maneuver, and the antenna patterns aren't too good at the moment. So we have a weak signal strength.
Apollo 11, this is Houston, broadcasting in the blind. Request Omni Bravo. If you read us, request Omni Bravo. Out. Apollo 11, this is Houston, how do you read?
Goldstone still showing weak signal strength.
Apollo 11, this is Houston, how do you read, over? Apollo 11, this is Houston, do you read, over? Apollo 11, this is Houston. Radio check, over. Apollo 11, Apollo 11. This is Houston. Radio check, over. Apollo 11, this is Houston. Radio check, over. Roger, we're copying you about 5 by 2, very weak. Can you give us a status report, please? Understand you are using the high gain, over.
That's affirmative.
Roger, I read you very loud and clear, Buzz. Mike's pretty weak.
Roger, we've got the high gain locked on now, I believe, auto tracking now.
Okay, you're coming in loud and clear, but Mike is just barely readable.
Hello, it's Neil. How are you reading, Mike?
Loud and clear now, Mike, and we understand that you are docked.
That's affirmative. Houston, CDR, how do you read distance?
11 CDR, loud and clear, Neil.
Okay.
This is Apollo Control. Apollo 11's velocity now 21,096 feet per second. Distance from Earth 6,649 nautical miles.
All right, 11, this is Houston, over.
Houston, Apollo 11, go ahead.
Roger, when you commented on the Quad Bravo problem at separation, you're a little weak. Could you go through what you did after you noticed the talkback's barber pole again, please? Did we copy the, I guess it's the primary and secondary propellant talkbacks on SMRCS Quad Bravo 1 to barber pole and separation?
Roger, that is affirmative, and we moved that switch to the open position, and they went back to gray, over.
Roger.
This is Apollo Control. We're 34 minutes away from extraction of the lunar module from its adapter in the third stage of the Saturn. The crew has started pressurizing the LEM.
Apollo 11, this is Houston, over.
Roger, Houston, Apollo 11, go ahead.
Roger, could you give us some comments on how the transposition and docking went, over?
Yeah, I thought it went pretty well, Houston, although I expect I used more gas than I've been using in the simulator. The turnaround maneuver, I went pitch Excel command and started to pitch up, and then when I put manual attitude pitch back to rate command, for some reason it stopped its pitch rate, and I had to go back to Excel command and hit what I thought was an extra proceed on the diskey. Then During the course of that, we drifted slightly further away from the S4B than I expected. I expected to be out about 66 feet. My guess would be I was around 100 or so, and therefore I expect I used a bit more coming back in. But except for using a little more gas, and I'd be interested in your numbers on that, everything went nominally.
This is Houston. Roger, we copy.
That was Mike Collins giving the description on the transposition and docking.
Apollo 11, over.
Go ahead, 11.
Raj, we're working on the pressurization of the limb now and working off the decal at DSM limb pressure equalization. And we're down to step 13 where we're waiting for the cabin pressure to be 5, or it should be roughly 5, before we turn the repressed package O2 valve to fill. Instead of 5, we're running about 4.4, over.
Roger, stand by a second.
And Houston, Apollo 11, we did put the repress package O2 valve to fill momentarily there in step 13, and we have filled the bottles back up partially. What's the pressure reading there now, Neil? Now we have about 450 psi now in the 3 1-pound bottles.
Roger, stand by a second, please.
Roger, standing by, and the repress package valve is now in the off position. What's the cabin pressure now, bud? Cabin pressure is now 4.5.
At 3 hours 46 minutes, velocity is 18,917 feet per second. Distance from Earth, 9,002 nautical miles.
Houston, Apollo 11, we think these readings are within normal tolerances. We just wanted to get your concurrence before we pressed on any further with this decal.
Okay, Captain.
And Houston, Apollo 11, how do you read?
Apollo 11, this is Houston. Go ahead.
Limb looks to be in pretty fine shape. About all we can see from here.
Okay, in reference to your question on this step 13 on the decal, I understand that you have used up the contents of the repress O2 package, and at that time, instead of being up to 5 psi, you were reading 4.4. Is that correct?
Okay, 4-4, yes, sir.
Okay, and you want to know if you can go ahead and use additional oxygen to bring the command module up to 5.0 and continue the equalization? Over.
Yeah, we think it's within normal tolerances, Bruce. We just wanted to get your concurrence before we pressed on with this procedure.
Roger, Apollo 11. Go ahead.
Okay, we're pressing on with the procedure.
And 11, Houston, we have a request for you on the service module secondary propellant fuel pressurization valves. As a precautionary measure, we'd like you to momentarily cycle the 4 switches to the closed position and then release. As you know, we have no TM or talkback on these valve positions, and it's conceivable that one of them might also have been moved into a different position by the shock of separation. Over.
Okay, good idea. That's being done.
Houston, roger out. Apollo 11, Houston, we're doing a non-propulsive vent on the booster at the present time. You may see some sort of a cloud coming out of it, and when you're ready, I have your evasive maneuver pad.
Roger, that's coming out.
Roger out.
It's a haze that's going by toward our minus X direction, and several small particles are moving along with it. The actual velocity is fairly high. At least it appears to be high. And we've got an O2 high, low high right now.
Houston, roger out.
And Houston, you might be interested that out my left-hand window right now, I can observe the entire continent of North America, Alaska, over the pole, down to the Yucatan Peninsula, Cuba, northern part of South America, and then I run out a window.
Roger, we copy.
That was Neil Armstrong with that report.
Houston, Apollo 11, all 12 latches are locked.
Roger 11, this is Houston, understand 12 latches locked.
Houston, we're ready for LEM ejection.
Roger, go for LEM ejection.
Thank you. Houston, we are set. We have a cryo press light.
Roger, copy, cryo press light. Roger 11, we recommend you turn the O2 fans on manually and ensure that the O2 heaters are in the automatic position.
Roger, O2 heaters are on, and we're going to cycle the O2 fans.
Roger, O2 heaters to auto, or you can watch them in the on position, and O2 fans manual on. Apollo 11, this is Houston, over.
Houston, Apollo 11.
Roger, in reference to your question on RCS usage, it looks like you're about 18, maybe 20 pounds below nominal at the present time. No problem at all, over.
Right. Want to be 18, 20 pounds above nominal, babe.
Sorry about that.
This is Apollo Control at 4 hours 34 minutes. Apollo 11's velocity is 14,972 feet per second. Its distance from Earth is 15,895 nautical miles. Spacecraft weight, 96,760.9 pounds. We're about 5 minutes away from the evasive maneuver. That will ensure there will be no problems of recontact between the spacecraft and the S-4B stage of the launch vehicle.
Houston, your systems are looking good. We're standing by for the burn.
The duration of this burn will be 3 seconds. Delta V 19.7 feet per second. Ignition. Shut down.
Houston, Apollo 11, could you confirm that pitch gimbal motor number 1 turned off? We just shut all 4 off and we got a questionable indication on the ECS on pitch 1.
Roger, stand by a second. Apollo 11, this is Houston. Stand by, please.
Go ahead, Houston. Did you copy our residuals?
Right, we got 00 and .2, it looks like.
We had .1 a while ago. It just went to .2.
Okay. Apollo 11, this is Houston. If you go ahead and cycle pitch gimbal motor number 1 on and then off and give us a mark, and we'll tell you what we see, over.
Okay, fine. It's coming back on. Ready, mark. It's going back off. Ready, mark. And that time we got an onboard indication, Houston. Thank you a lot.
Roger, we confirm that it is off.
Yeah, we do likewise.
This is Apollo Control at 4 hours 44 minutes. A news conference at the Kennedy Space Center is about to begin. We will take down the live circuits and tape air to ground during this news conference, play it back after the conference. This is Mission Control, Houston. This is Apollo Control at 5 hours 11 minutes into the mission. The S-4B slingshot maneuver was completed about 5 minutes ago, designed to put the third stage of the launch vehicle into a trajectory that will take it behind the trailing edge of the moon and then into a solar orbit. The crew did not witness this maneuver. The command module was not in the proper attitude where they could see the S-4B at the time. We've advised the crew that we do not believe that we'll do the first mid-course correction, that we'll wait for mid-course correction 2 tomorrow and expect a delta V to be performed in that maneuver of about 21.3 feet per second. We've also had some other brief transmissions, including comments from Neil Armstrong on the view out the window and a weather report on the part of the world he can see. We have the tape of these transmissions that have occurred during the news conference at the Cape. We'll play that for you now and catch up live.
Houston, Apollo 11, we're starting our maneuver to observe the S-4B slingshot.
Roger, 11. We've got an updated attitude for you on the slingshot observation.
Okay, say the angles, please.
Roger, roll 002.5, pitch 289.3, yaw 357.5, and there's also an update, minor correction to your attitude for the P-52. Over.
Roger, I have rolled 2.5, pitch 289.3, and yaw 357.5. Over.
Roger. And for your P-52 and optics calibration, it'll be roll 346.5, pitch 345.0, yaw 007.8, over.
Roger, 346.5, 345.0, and 7.8, thank you.
Houston, roger out. Apollo 11, this is Houston, over.
Roger, go ahead, Houston, Apollo 11.
Roger, we're going to go ahead and enable the S4B for the slingshot maneuver. The lock dump will start about 12 minutes from now, over.
Okay, lock stump about, I guess that'll make it about 01.
Right, I'll try to give you a little closer update as we approach it.
Alrighty.
And 11, for your information, the magnitude of mid-course correction number 1, if we burned it, looks like about 17 feet per second. We're presently considering not burning it. This would make mid-course correction 2 tomorrow about 21.3, over.
That sounds good to us.
Roger, you're looking good down here.
Yeah, we didn't have much time, Houston, to talk to you about our views out the window when we were preparing for limb ejection, but up to that time we had the entire northern part of the lighted hemisphere visible, including North America, the North Atlantic, and Europe and Northern Africa. We could see that the weather was good just about everywhere. There was one cyclonic depression in northern Canada and the Athabasca, probably east of Athabasca area. Greenland was clear, and it appeared to be we were seeing just the ice cap in Greenland. All North Atlantic was pretty good, and Europe and Northern Africa seemed to be clear. Most of the United States was clear. There was a low, looked like a front stretching from the center of the country up across north of the Great Lakes and into Newfoundland.
Roger, we copy.
I didn't know what I was looking at, but I sure did like it.
Okay. I guess the view must be pretty good from up there. We show you just roughly somewhere around 19,000 miles out now.
I didn't have much outside my window.
We'll get you into PTC one of these days and take turns looking.
Houston, Apollo 11, we've completed our maneuver to observe the slingshot attitude, but we don't see anything. No Earth and no S4B.
Roger, stand by. In GET, I have a lock dump start time for you. It's supposed to start at 5 plus 03 plus 07 and stop at 5 plus 04 plus 55. LH burn starts at 5 plus 37 plus 47. Stops at 5 plus 42 plus 27. Over.
Roger, thank you.
11, Houston.
Go ahead, Houston.
Roger, we now recommend the following attitude. Roll 307.0, pitch 354.0, yaw 019.5, and the lock stump has already been enabled, so we can't hold it off any longer.
That's okay. Go ahead. We'll maneuver around to 307, 354, and 19.5. Thank you.
Roger. 11, Houston. It doesn't look to us like you'll be able to make it around to this observation attitude in 2 minutes. We recommend that you save the fuel. Over.
Okay, Houston, you got to it just a little late. Our maneuver has already begun, so it's going to cost us about the same amount of fuel to stop it. No matter where we stop it in, we may as well keep going.
Roger, go ahead. 11 Houston, lock stump initiated. 11 Houston, lock stump has been terminated, over.
Roger. Roger, we still don't have the sight.
Roger, out. Apollo 11, this is Houston, over.
Go ahead.
Roger, if you'll give us accept and stay in poo, we'll set your trunnion bias to 0. And I have a plan for balancing your oxygen cryos, over.
You got it.
Roger.
Houston, Apollo 11, we've got the what appears to be the S4B in sight. I'd estimate a couple miles away. It's at a number 5 window. And the Delta appears to be coming out of two radially opposite directions from the S4B.
Roger. They're continuing with a non-propulsive vent from the liquid oxygen tank. It would be radially opposite there. And boosters tells me that it's the continuous vent system. They're also dumping a small amount of fuel at this time. We've got about 23 and a half minutes or so until the apps burn, over.
Roger.
11 Houston, we have a recommended configuration for your cryo switches to even up the load between oxygen tanks 1 and 2, over. Okay, you're coming in very weakly there. We're recommending O2 tank 1 heater off, O2 tank 2 a heater to auto, O2 tanks 1 and 2 fans both off, H2 tank 1 heaters to auto, and H2 tank 2 heaters to off, over.
Roger, we have that, except the last one was H2 fans to off. Is that affirmed?
H2.
We have the configuration we have now is hydrogen heaters. We got 1 auto, 2 off. Oxygen heaters, 1 off, 2 auto, and we have all the fans off.
This is Houston. Roger, we concur. Out. 11, this is Houston. We've completed the trunnion 0 bias setting. You can retrieve the computer and go to block.
Roger that, thank you.
11, this is Houston. With this maneuvering to observe the slingshot, I guess we missed copying your LMCM Delta P reading, over.
Stand by, we'll give you a reading.
Roger.
Right now, reading 0.2, Bruce.
Roger, 0.2. Okay, Mike, and could you verify that your waste compartment valve was in vent there?
Roger, waste compartment valve has been in vent for, I guess 45 minutes or so.
Roger, we copy.
If we're late in answering you, it's because we're munching sandwiches.
Roger, I wish I could do the same here.
Don't leave the console.
Don't worry, I won't.
Flight doesn't like it. How is flight today?
Oh, he's doing quite well.
This is Apollo Control at 5 hours 22 minutes. We're back live now. The Delta P you heard discussed is the difference in pressure between the LEM and the command module, cabin pressure. Apollo 11 coming up on 22,000 miles distance from the Earth now. velocity 12,914 feet per second.
Houston, 11.
Go ahead, 11.
Down the control center, you might want to join us in wishing Dr. George Miller a happy birthday.
Roger, we're standing by for your birthday greeting.
I think today is also the birthday of California, and I believe they're 200 years old. We send them a happy birthday, and I think it's Dr. Miller's birthday also, and I don't think he's that old.
Roger, we copy. I'm looking back in the viewing room right now. I don't see him back.
May not be back from the Cape yet.
Roger, I believe Dr. Miller's on his way back from the Cape. We'll relay his greetings for you.
Thank you.
This is Houston, over.
Go ahead, Houston.
Roger, at your convenience, we'd like to get a wastewater dump to 25% remaining. After completion of this one, the next wastewater dump will be at about GET equal to 25 hours, over.
Coming on right now.
Roger.
This is Apollo Control at 5 hours 31 minutes into the mission. Apollo 11's velocity now 12,637 feet per second. Distance from Earth 22,971 miles. Spacecraft weight 96,573 pounds. This is Apollo Control at 5 hours 55 minutes. Apollo 11's velocity 11,970 feet per second. Distance from Earth 25,671 nautical miles.
Houston, Apollo 11.
Go ahead, 11.
Roger, do you have any update for the roll, pitch, and yaw angles on the top of page 37 in the flight plan, or are they still good?
That's for the optics calibration?
Yes, sir.
Yes, indeed. I'll give them to you in just a second here. Roger, 11. For the optics calibration, I've got 346.5 for a roll, 345.0 for pitch, and 007.8 for yaw. The pen and ink attitude corrections in your book for P23 are good. Over.
Okay, thank you.
And we're going to hand over to Hawaii in about 5 or 6 seconds here. We'll have a momentary comm dropout.
Roger.
Hello, Apollo 11, Houston. Be advised, your friendly white team has come on for its first shift. If we can be of service, don't hesitate to call.
Thank you very much. Yeah, we're about to take our marks, Charlie, on this P23 optics cal. I've got it in the sextant now, and I'm about to split the image and mark.
Roger, Mike. We're watching.
The Capcom is now Charlie Duke, and Gene Kranz and his white team of flight controllers is preparing to take over the responsibility here in the control center from Cliff Charlesworth's team. This is Apollo Control. It's 6 hours, 16 minutes into the mission. Velocity now 11,479 feet per second. Apollo 11's distance from Earth, 27,938 nautical miles. We're estimating the change of shift news conference for 3:30 p.m. Central Daylight Time.
Hello, Apollo 11, Houston. We have scrubbed mid-course 1, over.
Roger, understand. You scrubbed mid-course 1.
Roger. Hello, Apollo 11, Houston. We see your middle gimbal angle getting pretty big, over.
Well, it was, Charlie, but in going from one auto maneuver to another, we took over control and have gone around gimbal lock, and we're about to give control back to the down.
Roger, Mike. We see it increasing now.
Houston, Apollo 11.
Go ahead, 11, over.
Hey, maybe you better call Lou and tell him we might be a little bit late for dinner.
Okay, sure will. We'd like you to turn on the fan on in O2 tank number 2, Buzz. And 11, did you, on your optics calibration, did you proceed or recall the program, over?
We recalled the program.
Roger.
And O2 fan number 2 is on.
Roger.
Houston, Apollo 11, got a ground pressure light and a master alarm. It's reset.
Roger, we expected that. That's why we had your turn the fan on. We were getting pretty close to the caution and warning limits. We were trying to prevent that.
Okay.
This is Apollo Control at 6 hours, 31 minutes. At the present time, the spacecraft is 29,363 nautical miles from Earth, and the velocity continuing to drop off gradually, reading now 11,192 feet per second. Flight Director Gene Kranz has taken over as Flight Director now from Clifford Charlesworth. Kranz has been reviewing the status of the spacecraft systems with his team of flight controllers. Everything looks very good at this point. The crew has been advised that the mid-course correction 1, the first opportunity for a mid-course correction, which had been scheduled into the flight plan at about 13 hours, 30 minutes, will not be performed. Correction, the mid-course had been scheduled at 11 hours 45 minutes into the flight plan, and that will not be performed according to the tracking data we have at this time. The crew, up until their sleep period, which will begin at about 13 hours 30 minutes, or about 7 hours from now, will be involved generally in a routine of housekeeping-type activities aboard the spacecraft. At the present time, they should be involved in some mid-course navigation. At 6 hours 32 minutes, this is Apollo Control, Houston.
Houston, Apollo 11.
Go ahead, 11, over.
Roger, you're looking at our Delta V. It looks like Delta R is pretty large there. We wanted to talk to you about it before we incorporate it.
Stand by, Mike. We don't have anything on our downlink here, I don't think, on the disking. Stand by.
Okay, our noun 49 is reading register 1 plus 087903, register 2, all balls.
Copy. 11, Houston. Guidance is looking at the noun 49 stuff. We'll be back with you momentarily, over.
Okay, Charlie, thank you. We'll just hold right here in the program.
Roger, we got the downlink now, over.
Okay.
Hello, Apollo 11, Houston. We'd like you to reject the noun 49 stuff on the disky right now, Mike, and try it again, over.
Okay, will do. Okay, Houston, Apollo 11. There's another 49 for you. Are you getting it on the downlink?
Roger, we see it. Stand by. Hello, Apollo 11, Houston. We recommend you accept the noun 49 display on the disky now, over.
Okay, looks like an awful big one. We noticed that you'd moved star number 2 to the tail end of the listing, and we should be marking first on star 40. Does that have anything to do with it?
Negative. We don't believe so, Apollo 11. We think that this is probably due to some TLI dispersions, and it's probably satisfactory to go ahead and accept this. It fits our criteria anyway, that if you repeat the marking, you get an equivalent size error, to go ahead and accept it. And this is an equivalent size error, over.
Okay, we'll do it then.
And 11, Houston, your state vector and limb slots is good, over.
Roger, thank you. Houston, Apollo 11, if you like this one, we'll accept it as well.
Stand by. Hello, Apollo 11, Houston. We recommend you accept the noun 49, over.
Okay, Charlie, thank you. We'll do that now.
Thank you.
And we're going to proceed on this one too, Charlie.
Roger, copy.
Houston, Apollo 11, another noun 49 for you.
Roger, we copy. Stand by. Hello, Apollo 11, Houston. We'd like you to recycle and do this one over again, over.
Okay.
This is Apollo Control at 6 hours 52 minutes. Apollo 11 now 31,565 nautical miles from Earth, and the velocity is 10,789 feet per second. The crew at this time is involved in mid-course navigation using their onboard optical system. We have completed the changeover and briefing of shifts here in Mission Control, and the crew activities until the sleep period begins will consist of housekeeping, functions aboard the spacecraft, changing out carbon dioxide filters. They will not be doing the mid-course correction scheduled for 11 hours 45 minutes into the flight as the first opportunity. The change of shift briefing is scheduled to begin shortly. Any conversations that develop with the crew during that period of time will be tape recorded. We'll play those back following the change of shift briefing. This is Apollo Control at 6 hours 53 minutes. This is Apollo Control, 7 hours 21 minutes into the flight of Apollo 11. And during the change of shift briefing, we accumulated about 4 minutes of taped conversation with the spacecraft. That conversation generally related to the onboard batteries, which are currently being charged, a routine operation, and also the mid-course navigation exercise that the crew is currently involved in. We'll play back the tape for you now and then stand by for any live conversation with the crew.
Houston, Apollo 11.
Go ahead, Apollo 11, over.
Raj, why don't you sing out when you think we've done enough battery charging on B?
Raj, stand by, Buzz, over. Hello, Apollo 11, Houston. We'll be charging battery B up until the sleep period. We'll discontinue charging at that time. Also, at about 12:25 in the flight plan, we have battery A charge. That has been deleted, over.
Raj, understand we'll charge until the sleep period on B and delete the battery A charge.
A firm.
Yeah, Houston, Apollo 11, these auto optics maneuvers, or P-23's auto maneuvers, don't seem to be going to the substellar point. Can you come up with the roll, pitch, and yaw angle for the substellar point on this star? It's our second star.
Roger, stand by. Hello, Apollo 11, Houston. Your angles in the flight plan, we feel is still good. 198.6, 130.7, 340.0. Just slightly off than those in the flight plan, over.
Okay, we'll try that.
Charlie, say those three angles one more time. I'd like to confirm them before I maneuver.
Roger, roll and pitch are slightly off than what's in the flight plan. 11, roll is now 198.6. Pitch is 1307, over.
Roger, roll 198.6, pitch 130.7, and yaw 34000.
That's affirmative.
Houston, Apollo 11, I think the problem here is that that attitude just is not too close to the substellar point. I'm having to maneuver quite a bit, and that's in progress now, so stand by for some more.
Roger, we copy it. Oh. Hello, Apollo 11, Houston. We've run the angles given in the flight plan for the P-23 attitude through the machines down here, and they come up the same thing every time. We think everything's going correctly, Mike, and we're wondering if the non-symmetrical horizon might be giving you a problem, over.
Yeah, it could be, Charlie. Stand by here. We'll get another mark for you.
Okay.
Houston, Apollo 11, noun 49 for you.
Roger, copy. Stand by. Hello, Apollo 11, Houston. We recommend you accept the noun 49, continue through your sequence of sightings, and then we'll analyze the data afterwards. Over.
Okay. Houston, Apollo 11, star 40 has just disappeared now in the sextant. Could the trunnion angle 47 something be a little high?
Stand by. Hello, Apollo 11, Houston. We'd like you to press on to star 44. Over.
Yeah, Roger. How many marks have you recorded on star 40?
Stand by, Mike.
Okay.
11, Houston, we copied 2 good marks. Over.
Okay. Houston, Apollo 11.
Go ahead, over.
Roger. 44 is just not bright enough for this. There's a reddish glow filling the black area of the sextant, and the star is lost somewhere in there, and I cannot see it.
Roger, stand by. We'll come up with another star. Over.
Yeah, I appreciate that.
Hello, Apollo 11, Houston. We'd like you to go on to star 45. Over.
Okay.
And Mike, we think these large Delta R's, noun 49 you're getting is really meaningful since it's been way before TLI since we had our state vector update, and we think it's normal. Over.
Okay, could be, Charlie. Some of the early markings I might not have had precisely the substellar point. I think as time goes by, they've been becoming more accurate, but old enough here is just flat invisible.
Roger.
And Houston, Apollo 11, understand that the same 3 gimbal angles you gave me should be valid for star 45 as well. Is that affirmative?
I believe that's right. Stand by 1. Over.
Okay.
That is negative. Stand by 1.
Okay, because there's quite a difference between the gimbal angles you have and the gimbal angles the program was. But with inaccurate state vector, I'm inclined not to believe the program.
Stand by.
Houston, Apollo 11, LMP is back on the line.
Roger, copy.
Ready, bye-bye.
Roger, same, Buzz. And 11, the angles for you are 1978 for roll, 1285 pitch, 3400 yaw.
Okay, just as a matter of comparison, P23 for this star would like to go to 235.66, 154.31, and 31365. Over.
Roger, we copy 11. We understand that the program can give you almost an infinite combination of angles in P23, and it's not too unreasonable. If you'll stand by, we'll look at these that we see on the disky. Over.
Okay, well, in the meantime, I'll just go ahead and maneuver to yours. 197.8, 128.5, and 340.0.
Roger.
Houston, Apollo 11.
Go ahead, over.
Okay, Charlie, at the attitude you gave me on star number 45, The reticle is off, I'd say, a good 30 degrees in roll, and the star is not in sight, over.
Roger, stand by.
I think something's wrong with those attitudes.
Hello, Apollo 11, Houston. Wondered if you have auto optics selected, over.
That's affirmative.
Roger, it looks like to us we need to proceed, Mike, to get the sextant pointed at the star, over.
Okay, stand by.
Houston, those shaft and trunnion angles were exactly what we were computing on the ground, over.
Okay, I'm going to trim up the attitude here and give it another try. Okay, I have this star loud and clear now, Charlie, so I might as well do a bunch of marks on this one to get a good horizon count.
Roger, stand by.
It still looks like I'm far from the substellar point, however. I'm off quite a bit in roll. It still looks like I'm far from the substellar point, however. I'm off quite a bit in roll.
Roger, we'd like you to mark right where it is now, Mike, and we'd like 2 sets of marks on this, over.
Okay, fine, but the reticle is not parallel to the horizon. I'd have to move off quite a bit in order to get it parallel to the horizon.
Apollo 11, Houston, our procedures guys are saying that the reticle does not have to be parallel, over.
Well, then we're not at the substellar point if we're not. Houston, you copy that now, 49?
Roger, we see it, 11, stand by. Apollo 11, Houston, we'd like you to accept this one and every mark thereafter, over.
Okay. You need me to wait in the now 49 display for any length of time?
Negative.
Okay. Okay, Charlie, I'm glad to give you as many of these as you like.
Roger, we'd like 6 marks on star 45, Mike, and then we'll probably go back to star 2 again. Stand by, we'll have further word on that.
Okay. Well, they seem to be getting smaller, Charlie. You sure you wouldn't like some more?
Stand by, Mike.
It's no trouble.
Right, stand by, out. Apollo 11, Houston, we'd like you to do 2 more on star 45, over.
Okay. Okay, Charlie, there's your 2 more marks. Where do you want to go from here?
Stand by. Hello, Apollo 11. Houston, we'd like you to go back to star number 2 with a attitude as follows. Roll 1952. Pitch 123-9er. Yaw 3400. Mike, that'll give you a trunnion angle of about 31.4, over.
Okay, understand star number 2 and roll 195.2, pitch 123.9er, and yaw 340.0. Over.
That's affirmative.
Okay. Okay, Charlie, I'm there, and I got a trunnion angle of 30.5 degrees. Again, I'm misaligned considerably in roll, and I do believe that's important to getting good marks.
Stand by.
You see, if my reticle's not parallel, well, then I'm not marking normal to the horizon. I'm not marking at the substellar point. I'm marking off somewhere else.
Stand by, 1 over.
Okay.
Apollo 11, Houston, the ground computed values for your shaft and trunnion are just what you're getting on a disky there, Mike. The horizon looks cocked off to you. You look like you're off in roll because of the angles that we gave you to maneuver to prevent the limb reflection from fouling up your optics. We feel like you should go ahead and mark on the star just as is. Over.
Okay. I'll bet you a cup of coffee on it.
Copy.
Or noun 49 for you, Charlie.
Roger, stand by. Apollo 11, Houston, we'd like to accept this one and give us 2 more, and that'll be enough. Over.
Okay.
This is Apollo Control at 8 hours, 8 minutes. Apollo 11 now 38,812 nautical miles from Earth and traveling at a speed of 9,682 feet per second. And we'll just put in a call to the crew. We'll stand by for.
Charlie, it just appears to me that you have to have the reticle tangent to the horizon at the point at which you mark, or else you're not at the substellar point. You're off laterally, and therefore you're measuring a larger trunnion angle than you should.
It seems so to me. Our procedures people are working on this, and we'll be back with you momentarily. Over.
Thanks, sir.
Hello, Apollo 11, Houston. We'd like you to go poo and accept. We'll have a PTC rest mat for you momentarily. Over.
Roger. Go on poo and accept.
The PTC rest mat, which Capcom Charlie Duke just referred to as the passive thermal control attitude that the crew will place the spacecraft in. In this attitude, the spacecraft will be rotated at a rate of about 3 revolutions per hour to maintain the proper temperature balance.
Hello, Apollo 11, Houston. We're through with the load. You can go back to block.
Good block, thank you.
Hello, Apollo 11, Houston. We'd like you to do a P-52 option 1 preferred and establish PTC as listed in the flight plan at 12 hours. We'd like you to commence that right now, Mike. And we have some stars recommended for you for stars 26, 30, and 24 when you get to attitude 000. Over.
Okay, Charlie, he's off the loop right now. Understand you're ready for us to do a P-52
Option 1.
11, it's a P-52, option 1 preferred, over.
And let's see, is it Spica, Bandcamp, and what else?
Roger, stars, codes are stars 2630 and 24, over.
24, okay.
Oh, Apollo 11, Houston, we noticed your program alarm, Mike, was due to using these stars in a P-23 attitude. If you'll go to 000, the stars we gave you will work, over.
Okay. Understand.
Hello, Apollo 11, Houston. Prior to you starting your P-52, we'd like to give you a new CSM state vector, over.
Roger.
When we finish the maneuver, and we'll give you the distance.
Roger, we're standing by.
Houston, Apollo 11, the disc is yours.
Apollo 11, Houston, go ahead, over.
Roger, the disc is yours.
Roger, stand by.
This is Apollo Control at 8 hours 59 minutes into the flight of Apollo 11. The spacecraft altitude is currently reading 42,753 nautical miles, and we show a velocity of about 9,100 feet per second. We are in the process now of uplinking to the spacecraft the attitude for the passive thermal control mode. Under this mode, the spacecraft will be rotated about its x-axis at a rate of about 3 revolutions per hour to maintain proper temperature balance within the spacecraft. The crew has completed the mid-course navigation exercise. They will shortly be aligning the spacecraft stable platform used as an attitude reference in the guidance system. This is a routine procedure. And following that, the spacecraft will be placed in the passive thermal control mode, where normally it would be left during the sleep period. The cabin temperature in the command module has been running between 65 and 70 degrees. The current spacecraft weight is 96,460 pounds.
Hello, Apollo 11, Houston, you can do the Verb 66, the computer is yours, and then the P-52, option 1 preferred, over.
Roger.
Apollo Control at 9 hours 13 minutes into the flight of Apollo 11. Based on biomedical data, a flight surgeon reports it appears the crew removed their pressure garments, their pressure suits, at about 8 p.m. for the commander, Neil Armstrong, and command module pilot Mike Collins. Lunar module pilot Buzz Aldrin apparently got out of his pressure suit about 1 hour earlier, or about 7 hours ground elapsed time. The spacecraft is currently 44,529 nautical miles from Earth, and the velocity has dropped now to 8,983 feet per second. We do have rather poor lock with the spacecraft antenna at this time, accounting for the noise on the air-to-ground circuit. We'll take down the circuit until we've reestablished better lock, and we'll record any conversations that occur in the interim. At 9 hours 14 minutes, this is Apollo Control, Houston. This is Apollo Control at 9 hours 36 minutes into the flight of Apollo 11. The mission continuing to go smoothly at this point. The communications noise that we were experiencing previously cleared up after the crew was able to get the spacecraft in a good attitude for antenna lock-on. And we had one brief conversation which we taped. We're presently communicating with the crew at this time. We'll pick up the tape and then continue to follow live conversation.
Houston, Apollo 11, over.
Roger, 11, read you about 4 by Army, over.
You're loud and clear, Charlie. We pitched down some to get a better comm attitude.
All right, did you copy our recommendation on proceeding with the P-52, Mike, over?
Negative, we didn't. I've got that in work. I'm starting on P-52.
Roger.
Houston, Apollo 11.
Go ahead, 11, over.
Roger, you copy our torquing angles. We're about to torque them.
Roger, stand by.
All right, the reason for the delay there, Charlie, is that it's difficult to find two stars that are not occulted by the limb and also are not in the midst of a man-made star field up here with dumps.
Roger, we copy.
Okay.
Hello, Apollo 11. Houston, you can torque to now 93, over.
Okay.
That brings us up to date with the taped conversation that we had. We'll continue to stand by for any live communications with the spacecraft. Most of that conversation with Mike Collins involved the platform alignment that the crew is involved in at the present time, aligning the stable platform used by the guidance system as an attitude reference. Apollo 11 is presently 46,688 nautical miles from Earth, and the velocity is 8,750 feet per second.
Okay, Houston, that completes the P-52. We verified the third star with Antares, and the auto optics are pointing at it pretty closely. How do our platform drift angles look so far, Charlie?
Stand by. Hello, Apollo 11. Houston, we didn't have a chance to get a drift check for you. We're going to run a drift check from this alignment till the next one in approximately 12 hours, and we'll have something for you later, over.
Okay.
Hello, Apollo 11, Houston. We'd like you to establish your PTC. We recommend you select quads Alpha and Delta, over.
Roger, understand Alpha and Delta quads for PTC.
That's affirmative. Hello, Apollo 11, Houston. Would you verify that the attitude set switch is in GDC, over?
Set. Stand by one, Joey.
Roger.
It is now.
Roger. It was an IMU?
That's affirmative.
All right, thank you.
Hi, Houston, Apollo 11. How many miles out do you have us now?
We have you standby, Buzz. Roughly about 50,000 standby.
It's a beautiful sight.
Charlie, on the PTC, we're just waiting our 20 minutes here for all thruster activity to damp out. You might let us know how that's coming.
Roger, will do. We have you about 48,000 miles now.
Thank you. Houston, Apollo 11, we still have our oxygen fan on for tank 2. Is that what you want?
Stand by.
Hey, Charlie, I can see the snow on the mountains out in California, and it looks like L.A. doesn't have much of a smog problem today.
Roger, Buzz. Copy. Looks like a good view out there then. And Apollo 11, Houston, we'd like you to keep the O2 fan on, and we'll give you an ECS configuration prior to sleep. Over.
Okay, fine.
Charlie, with the binocular, I can discern a definite green cast to the San Fernando Valley.
Roger.
Yeah.
How's Baja California look, Buzz?
Well, it's got some clouds up and down it, and there's a pretty good circulation system, a couple hundred miles off the west coast of California.
Roger. 11, we'd like you to close the waste storage vent valve right now.
Okay. Waste storage vent valves closed.
Copy. Apollo 11, Houston, we'd like, the rates are looking pretty good right now on the PTC, but we'd like you to continue holding. Over.
Okay, fine.
Houston, you're 11.
Roger, go ahead, 11, over.
Roger, if you'd like to delay PTC entrance for 10 minutes or so, we can shoot you some TV of a 7/8 Earth. We'll leave that up to you.
Roger, stand by. Hello, Apollo 11, Houston, we'll have an answer for you on the TV in about 1 minute. Over.
This is Apollo Control at 10 hours, 26 minutes into the flight of Apollo 11.
Houston, we're ready at Goldstone for the TV. It'll be recorded at Goldstone and then replayed back over here. Niels, anytime you want to turn her on, we're ready. Over.
Okay, it'll take us about 5 minutes to get rigged.
Roger.
Capcom Charlie Duke advised the crew that we would be recording the television at Goldstone. We don't have an estimate at this time as to how long it will take to get a playback of that from Goldstone.
Could you verify the reading on your O2 flow indicator? Over.
We're showing point 2.
we just inadvertently touched the rapid repress button. That made a temporary glitch in the flow. Roger, during that glitch there, did it go almost a peg high over? Yeah, I believe that. Apollo 11, Houston, could you tell us if the O2 flow indicator was pegged to high prior to closing the waste storage vent valve, over? No, it was not. Roger, thank you. Apollo 11, Houston, a while ago we tracked into the scan limits and disabled the auto drive on the high gain. We'd like you to position the antenna at pitch 30, yaw 270, go to react. That will give us a narrow beam width, over. That yaw 270 and pitch 30. What was the pitch? Pitch 30, Neil. Okay. I think we've got you. Roger, we got a good signal now. Thank you much. Okay, Houston, we are sending a picture of Earth down right now, so you can let us know if they're receiving in Goldstone. Roger, 11, Goldstone is receiving the TV. Stand by, we'll let you know on the quality, over. Oh, Apollo 11, Houston, Goldstone says that the TV looks great, over. Okay, Roger, we're navigating on Earth now. Hello, Apollo 11, Houston, did you copy, over?
Roger, we copied, Charlie.
Roger, your transmissions the last couple of times have been about 2 by, over.
Okay, how do you read me now?
Roger, you're 5 by now.
Okay, we're zooming the lens on end so we'll just about fill the monitor.
Roger.
Okay, it's in full zoom now.
Copy 11.
And how about the f-stop? Is 22 going to be adequate?
Stand by. We'll get with the Goldstone TV guy. We don't have anything here at Houston. Stand by.
Yeah, that's right.
It looks good on the monitor as far as the f-stop goes, therefore we just assume it's okay. It's all right.
Hello, Apollo 11. Houston, Goldstone says that TV looks really great. 5 by. The AGC looks like it's working fine. The F-22 is good. We have no real white spots. They're real pleased with it, over.
Okay, you just cut out, Charlie. We understand that it's looking great. We'll leave it the way it is and wait for you to come back on.
Roger, how do you read me now, over?
5 by.
Okay, my comments were from Goldstone that they see no white spots as we saw in 10. Looks like the AGC's working real well. The F-22 looks good, over.
Okay, very good. Well, we shut out the sun coming in some of the other windows into the spacecraft, so it's looking through the number 1 window, and there isn't any reflected light. now, so it ought to be a pretty good picture.
Roger. Oh, Apollo 11, Houston, we'd like you to keep the TV on for about 10 minutes or so we can get some good comparison on the camera. You can do anything your heart desires on the TV, interior, exterior, pan in and out, anything you'd like, over. Houston, over.
Houston, Apollo 11, over.
Roger, go ahead, over.
Charlie, I'm sorry, you keep cutting out. We heard up to you can do anything, and then after that, we didn't hear anything, and we knew that wasn't right anyhow, because we can't. But what do you want us to do?
Roger, we'll check the uplink on our voice. Our transmission on the TV was we'd like to get about 10 minutes worth of signal at Goldstone so we can look at the camera quality back here at Houston for about 10 minutes or so when they patch it back into us. What we were saying was that you can go interior or exterior on the camera. On the exterior shots, we'd like a little... Stand by.
Start over with, we were saying. Hey, Houston, you suppose you could turn the earth a little bit so we could get a little bit more than just water?
Roger, 11. I don't think we got much control over that. Looks like you'll have to settle for the water. Houston, we're going to thinking about changing our voice uplink to another site. If you'll stand by, we'll see if we can improve the quality, over.
Okay, Charlie.
We'll stand by for your call.
Apollo 11, Houston, we'll try once more on this TV request. We'd like 10 minutes worth of TV, and we'd like a narrative, if you could give us one, on the exterior shots. We also suggest you might try an interior position, over.
Roger, we're seeing the center of the Earth as viewed from the spacecraft in the eastern Pacific Ocean. We have not been able to visually pick up the Hawaiian island chain, but we can clearly see the western coast of North America, the United States, the San Joaquin Valley, the High Sierras, Baja California, and Mexico down as far as Acapulco and the Yucatan Peninsula, and you can see on through Central America to the northern coast of South America, Venezuela, and Colombia. I'm not sure you'll be able to see all that on your screens down there.
Roger, Neil, we just wanted a narrative such that we can, when we get the playback, we can sort of correlate what we're seeing. Thank you very much.
I didn't see anything but the disky so far.
Looks like they're hogging the windows.
You're right.
Hello, Apollo 11, Houston. On your crowds, we'd like at this time for you to place all 4 crowd heaters to auto and turn off all 4 crowd fans, over.
Okay, all 4 cryo heaters are auto. And all 4
Roger, and that's going to be your sleep configuration.
Okay.
And Buzz, we'll be terminating the battery charge in about a half hour.
Roger.
Hello, Apollo 11. Houston, you can terminate TV at your convenience. We've got enough tape, and you can start PTC at your convenience. The rates look super for starting up, over.
Roger, Charlie.
This is Apollo Control at 10 hours 51 minutes. That TV transmission lasted about 15 minutes. Goldstone reported that we did get good quality on it. We estimate that it'll be somewhere between an hour and a half and 2 hours before we have the television available here in Houston to play back. The lines will have to be called up between Goldstone and Mission Control Center and the conversion equipment brought up online before we'll be able to play back the television from that transmission. At the beginning of the TV transmission, the spacecraft was approximately 50,980 nautical miles from Earth, and at the conclusion they were about 52,248 nautical miles from Earth.
Hello, Apollo 11, Houston. We have a flight plan update for you and some P-37 block data if you're ready to copy, over.
Stand by. Okay, Houston, PTC has started now. It looks good to us, and we'll be ready to copy in a minute or two.
Roger, copy 11.
Houston, Apollo 11, ready to copy the flight plan update and P-37.
Roger, stand by 1, Buzz. Apollo 11, Houston, coming at you with the P-37 block data, over.
Okay.
Roger. 02744 5363 minus 165 07314 03744 8016 minus 165 07246 GETI 04644 6141 minus 165 09703 05544 8209er minus 165 09642. They're ready for your readback, over.
Roger. 02744 5363 minus 165 07314 03744 8016 minus 165 07246 46. 04644. 6141. Minus 165. 09703. 05544. 8209er. Minus 165. 09er 642. Over.
Roger, 11. That was a good readback. That was the block data scheduled for 12 hours. We'd like to just say that on a flight plan update here, that just to remind you of some things, and you can do them at your convenience and then go to sleep early if you'd like. We don't have anything else planned. We'd like you to just to remind you on the filter change, the O2 fuel cell purge. We'd like a LIM CM Delta P and accomplish the pre-sleep checklist.
Okay, we've completed the filter change, and we'll get started on the fuel cell purge. And stand by for the LIM CM Delta P.
Roger, 11. Would you hold off on the fuel cell purge? ECOM saying we might not have to do that. Over.
Okay.
Charlie, the LIM CM Delta P is 0.5.
Copy, 0.5, out. Hello, Apollo 11, Houston. We just decided to delete the O2 fuel cell purge. Over.
Roger, delete the O2 fuel cell purge.
Hello, Apollo 11, Houston. We've been noting some funnies on the O2 flow indicator transducer. We kind of got a suspicion it's the transducer. We expected to see an O2 flow pegged high with the waste storage vent to vent. It was not. We also noticed some funny indications when you close the waste storage vent valve. We're going to continue to look at this through the night, and we'll be with you in the morning with an assessment of the problem. Also, we'd like to ask specifically, when you place the waste storage vent valve to vent, does the detent, does the error line up with the detent? Over.
Stand by one, Charlie. We'll give you something on the detent.
Roger.
Right now it's at closed, and I'm lined up with closed. Before I was at vent, and best I can recall, it was quite accurately lined up with vent. Would you like me to go to vent again momentarily and see where it lines up?
That's negative. That question's answered. Thank you much.
Okay.
This is Apollo Control. During that last transmission, you heard Capcom Charlie Duke advise the crew that we are not seeing as high an O2 or oxygen flow as we would have expected at this point. This would indicate that the enrichment of the cabin atmosphere, which was 60% oxygen, 40% nitrogen at launch, and which is normally enriched with pure oxygen during the course of the flight, is not enriching as rapidly as we would expect. This could be a transducer problem, one of the devices that measures the O2 flow rate, or possibly a partial obstruction of one of the vents. The problem is not thought to be significant at this point, and we'll be monitoring the O2 flow during the night.
Stand configuration for you. Over.
Roger, go ahead.
Roger, Buzz. We'd like you to place the S-band antenna Omni A switch to the Bravo position. S-band antenna Omni switch to the Omni position. The high gain track to manual. And the high gain angles will be yaw 270, pitch -50, over.
Roger, understand. Omni to Baker and Omni, manual, and the angles are yaw 270, pitch -50. And was that narrow or wide? Over.
Stand by. Roger, we'd like it in wide, and you can set that configuration up now, over.
That's in work.
Hello, Apollo 11. Houston, you can terminate the battery Bravo charge, and we'd like a crew status report. We're about to tell you good night, over.
Roger. Stand by. Houston, Apollo 11, the battery charging is complete, and the crew status report is as follows. Radiation, PDR 11002, CMP 10002, LMP 09003, negative medication, fit as a fiddle, over.
Roger, copy 11. Thank you much. We'd like to ask one question. Have you tried the gas separator on the water, and how is that working, over?
Yeah, Mike's got a couple of comments on that.
Yeah, it's working good so far, Charlie. We've got one installed on the water gun and the other one installed on the spigot down in the LEB. And we have... one problem with them is that they leak at the junction between the food bag and the water filter. However, with that exception, they seem to be working pretty good. We were getting some gas through initially, and I think that was just getting the system purged out to begin with. And the last tubeful we poured was almost free of bubbles, over.
Roger, sounds good. We'll check in on that problem with the span guys and let you know in the morning. If you have to call us tonight, we'd like you to do it on down voice backup. We're configuring the misspin for that mode, and as far as we can see, you're cleared for some Z's, over.
Okay, maybe we'll get around to lunch.
How about a peanut butter and jelly?
This is Apollo Control at 11 hours 29 minutes into the flight of Apollo 11. We don't expect to hear a great deal more from the crew tonight. At about 11 hours 20 minutes, we said goodnight to them from Mission Control. They're beginning their sleep period about 2 hours early. The additional time available for sleep was made available by deleting the mid-course correction, the first opportunity, which occurred at 11 hours 45 minutes. That mid-course correction has been moved to mid-course correction 2, to the opportunity at mid-course correction 2, which would occur tomorrow. The last conversation we had with the crew, we received a status report. They reported that they had taken no medication and were fit as a fiddle. We also got a report from Mike Collins on the gas separation unit, which is being flown on this flight. This consists of two stainless steel cylinders about 5 inches long and about an inch to an inch and a half in diameter. The cylinders are attached to the water gun or to the water spigot on the food preparation panel and remove the gas from the water as it flows through the filter. The filter actually has two filters inside, one which attracts water and one which repels it, in the process removing the gas. Mike Collins reported that the filters seemed to be working quite well, that the water was coming out almost free of bubbles. He did report that they had a minor problem with a leak at the junction between the food bag and the filter. Mission Control advised that we would give that some thought and try to come up with some solution to it when they wake up tomorrow. At this time, Apollo 11 is 55,522 nautical miles from Earth, traveling at a velocity of 7,920 feet per second. This is Apollo Control at 11 hours 32 minutes. This is Apollo Control at 11 hours 47 minutes into the flight of Apollo 11. At this time, we are receiving the television data from Goldstone. The data is coming in. It will be processed here and converted, and we estimate that it will be available for playback in about 20 to 30 minutes. And we will have a firm time on that as soon as possible. At the present time, Apollo 11 is 56,704 nautical miles from Earth, and the velocity is 7,821 feet per second. We've had no further conversations with the crew since we passed along a good night to them at 11 hours 20 minutes, getting them to bed about 2 hours ahead of the scheduled time on the flight plan as a result of the deletion of mid-course correction 1. At 11 hours 48 minutes, this is Apollo Control. This is Apollo Control at 12 hours 5 minutes. We expect to have the unscheduled television transmission, which came in to Goldstone, California, and was taped there and has been transmitted to Mission Control Center, ready and converted for replay in color at 8:45 p.m. Central Daylight Time. That would be about 7 minutes from now. The TV transmission runs for a total time of about 16 and a half minutes and is of an exterior shot out the window of the Earth. At the time of the transmission, Apollo 11 was some 50,980 nautical miles from Earth. A transmission came into Goldstone at a ground elapsed time of 10:32:40 and ended about 16 and a half minutes later when the spacecraft was at an altitude of 52,248 nautical miles. We'll stand by for a replay of that transmission at 8:45 p.m. Central Daylight Time.
Houston.
This is Apollo Control at 12 hours, 12 minutes. We expect to be ready to release the television transmission from the spacecraft, which was received at Goldstone, California. That should be ready to go in a little less than a minute. We are starting to get lock on from the tape replay, and we expect that we will have a color picture shortly.
Receiving the TV. Stand by. We'll let you know on the quality. Over. Apollo 11, Houston, Goldstone says that the TV looks great. Over.
Okay, Roger. We're coming in on Earth.
Hello, Apollo 11, Houston, did you copy? Over.
Roger, we copied that, Charlie.
Roger, your transmissions the last couple of times have been about 2 by. Over.
Okay, how do you read me now?
Right, you're 5 by now.
Okay, we're zooming the lens on in till it just about fill the monitor.
Roger.
Okay, it's in full zoom now.
Copy 11.
And how about the f-stop? Is 22 going to be adequate?
Stand by. We'll get with the Goldstone TV guy. We don't have anything here at Houston. Stand by.
Yeah, that's right. It looks good on the monitor as far as the f-stop goes. Therefore, we just assume it's okay. Cool, sir.
Apollo 11, Houston, Goldstone says that TV looks really great. 5 by.
Okay, you just cut out, Charlie. We understand that it's looking great. We'll leave it the way it is and wait for you to come back on.
Roger, how do you read me now? Over.
5 by.
Okay, my comments were from Goldstone that they see no white spots as we saw in 10. Looks like the AGC's working real well. The F-22 looks good. Over.
Okay, very good. Well, we shut out the sun coming in some of the other windows into the spacecraft, so it's looking through the number 1 window, and there isn't any reflected light. Now, so it ought to be a pretty good picture.
Roger. Houston, we'd like you to keep the TV on for about 10 minutes or so we can get some good comparison on the camera. You can do anything you're...
Apollo 11, over.
Roger, go ahead, over.
Charlie, I'm sorry, you keep cutting out. We heard up to you can do anything, and then after that, we didn't hear anything, and we knew that wasn't right anyhow, but we can. But what do you want us to do?
Roger, we'll check the uplink on our voice. Our transmission on the TV was we'd like to get about at Goldstone, so we can look at the camera quality back here at Houston for about 10 minutes or so when they patch it back into us. What we were saying was... we'd like a little... Stand by.
Start over with we were saying. You suppose you could turn the earth a little bit so we could get a little bit more than just water?
Roger, 11. I don't think we got much control over that. Looks like you'll have to settle for the water. Houston, we're going to thinking about changing our voice uplink to another site. If you'll stand by, we'll see if we can improve the quality, over.
Okay, Charlie. We'll stand by for your call.
Houston, we'll try once more on this TV request. We'd like 10 minutes worth of TV, and we'd like a narrative if you could give us one on the exterior shots. We also suggest you might try an interior position, over.
Roger. We're seeing the center of the Earth as viewed from the spacecraft in the eastern Pacific Ocean. We have not been able to visually pick up the Hawaiian island chain, but we can clearly see the western coast of North America, the United States, the San Joaquin Valley, the High Sierras, Baja California, and Mexico down as far as Acapulco and the Yucatan Peninsula, and you can see on through Central America to the northern coast of South America, Venezuela, and Colombia. I'm not sure you'll be able to see all that on your screens down there.
Roger, Neil. We just wanted a narrative such that we can, when we get the playback, we can sort of correlate what we were seeing. Thank you very much.
I didn't see anything but the disky so far.
Looks like they're hogging the windows.
You're right.
This is Apollo Control. The view that we have of the Earth disk at this time, as near as we can tell, the North Pole is to the left of the screen. The landmass that was visible was the western coast of the United States. The Earth then would appear to be rotated 90 degrees with the North Pole to the left, and the South American continent extending toward the upper right of the globe, but not visible.
Apollo 11, Houston, on your crowds, we'd like at this time for you to place all 4 crowd heaters to auto and turn off all 4 crowd fans. Over.
Okay, all 4 cryo heaters are auto. And all 4 cryo fans are off.
Roger, that's going to be your sweep configuration.
Okay.
And Buzz will be terminating the battery charge in about a half hour.
Roger.
TV at your convenience. We've got enough tape, and you can start PTC at your convenience. The rates look super for starting up, over.
Roger, Charlie.
That concludes the unscheduled television transmission. That transmission came in about 2 hours ago at a ground elapsed time of 10:32:40 beginning. Lasted about 16 and a half minutes. At the beginning of the transmission, Apollo 11 was about 50,980 nautical miles from Earth, and at the conclusion, about 52,248 nautical miles. At the present time, the crew is in a scheduled rest period. They did indicate before going into the rest period, when we last heard from them, that they would probably use part of the time to get a bite to eat and then get some sleep. At this time, Apollo 11 is 59,908 nautical miles from Earth, traveling at a speed of 7,569 feet per second. At 12 hours 31 minutes, this is Mission Control, Houston. This is Apollo Control at 12 hours 47 minutes. We've just put in a call to the crew. Flight Director Gene Kranz verified with the surgeon that they had not gone to sleep at this point, and Capsule Communicator Charlie Duke has put in the call. We'll pick up the tape of the conversation and then stand by for any following live communication with the crew.
All right.
Hello, Apollo 11, Houston. Hope we aren't disturbing you. We'd like you to terminate the Noun 65 now, over.
All right.
Apollo 11, Houston, over.
Houston, Apollo 11.
Roger. But when you stopped, or correction, when you terminated the Noun 65, it appeared to us you did a Verb 46, which collapsed the deadband back to 0.5. We're okay as long as you do not turn on any auto RCS select switches, over.
Okay. I thought that was clear way to clear the 50s, but that can't be enough. Roger.
Roger. Verb 34 would have been a better procedure.
Yeah.
This is Apollo Control. We don't anticipate a great deal of further conversation with the crew. We expect they will attempt to get some sleep shortly. The conversation that just ended, we advised that through one of the computer programs, the deadband, or that area of excursions which the guidance system will allow before firing the RCS thrusters to correct it, had been narrowed from 30 degrees to 1/2 a degree. What this would mean if the RCS jets were enabled is that unless the crew reselected the 30 degree deadband, the jets would be firing more frequently to keep the spacecraft within the narrower limits. Since the spacecraft is very stable at this point, very few wobbling motions, it was felt that the narrower deadband was acceptable. The jets are not enabled, and the crew would not be disturbed by firing of the reaction control system jets, even if the spacecraft moved out of the 1/2 degree deadband. In the event of any large excursions, which we would not expect based on the passive thermal control mode used in Apollo 10, it would be possible to awaken the crew from the ground and have the situation corrected. We would not expect, however, for the spacecraft attitude to change significantly during the night, and we do intend to continue in the passive thermal control mode as it is presently set up. At this time, Apollo 11 is 61,509 nautical miles from Earth, traveling at a speed of 7,449 feet per second, which would translate to about 5,000 miles an hour. At 12 hours 54 minutes, this is Apollo Control, Houston. This is Apollo Control at 13 hours 27 minutes into the flight of Apollo 11. The spacecraft now traveling at a speed of 7,279 feet per second, which would be about 4,963 miles an hour. And it's at a distance of 63,880 nautical miles from Earth. Our flight surgeon reported a short while ago that command module pilot Mike Collins appeared to be sleeping soundly at this time. Biomedical data on the other two crewmen indicates that they are still awake. We've had no further conversation with the spacecraft since our last report, and it appears that the crew will be getting some good rest, either as scheduled or perhaps a little earlier than scheduled in the flight plan. At 13 hours 28 minutes, this is Mission Control, Houston. This is Apollo Control. At 14 hours 6 minutes into the flight of Apollo 11, the mission is progressing very smoothly. All spacecraft systems are functioning normally at this time, and the flight surgeon reports that all three crewmen appear to be sleeping. For Commander Neil Armstrong and Lunar Module pilot Buzz Aldrin, they appeared to begin sleeping about 5 minutes ago. Command Module pilot Mike Collins has been asleep for about an additional 30 minutes to an hour. At the present time, Apollo 11 is 66,554 nautical miles from Earth and traveling at a speed of about 7,095 feet per second, which would be about 4,800 miles an hour. We've had no further conversation with the crew since our last report, and as I said, all three crewmen appear to be sleeping at this time. At 14 hours 7 minutes, this is Apollo Control, Houston. This is Apollo Control, 14 hours 25 minutes into the flight of Apollo 11. The spacecraft presently 67,819 nautical miles from Earth, traveling at a speed of 7,012 feet per second. Here in Mission Control, the shift change is in progress. Flight Director Glenn Lunny and his team of flight controllers coming on to replace Gene Kranz and his white team. The capsule communicator on the upcoming shift will be Ron Evans. And we anticipate that the change of shift briefing for this shift will begin in about 10 or 15 minutes. At 14 hours 26 minutes, this is Apollo Control, Houston.
This is Apollo Control, 15 hours 28 minutes, ground elapsed time. Apollo 11 crew still asleep, according to Flight Surgeon Ken Beers here in Mission Control. The flight crew is still sleeping soundly at this time, according to the biomedical telemetry being beamed down to the displays on his console. Here in the Mission Control Operations Room, or MOCR as it's called, the black team of flight controllers is settling in for the night, headed up by Flight Director Glenn Lunny. Some 7 hours remaining in the crew sleep period. Distance and velocity now showing 72,009 nautical miles out from Earth. Velocity now 6,750 feet per second. And at 15 hours 28 minutes ground elapsed time, this is Apollo Control. This is Apollo Control, 16 hours 38 minutes ground elapsed time. Apollo 11 presently being tracked by the Honeysuckle Creek, Australia tracking station. Geographically, the spacecraft is practically directly over or out from the Philippine Islands. Now showing some 5 hours and 51 minutes remaining in the crew rest period. Crew still asleep at this time. Continuing to decelerate as the spacecraft gets out toward the changeover point between the Earth's sphere of influence and the Moon's sphere of influence. Velocity now showing 6,493 feet per second. Apollo 11 now out 76,453 nautical miles from the Earth. And at 16 hours 39 minutes ground elapsed time, this is Apollo Control. This is Apollo Control, 17 hours 33 minutes ground elapsed time. Apollo 11 now some 79,700 nautical miles out from Earth at a velocity of 6,320 feet per second. Telemetry display for the crew biomedical readings now shows All three men in a fairly deep sleep. Mean heart rates in the 40s for all three men. Command module cabin pressure holding at 4.7 pounds per square inch. Cabin temperature 63 degrees. No measurements on the lunar module in terms of cabin pressure, and as much as the lunar module has not been activated and will not be until shortly before entering lunar orbit. The first manning, the lunar module is checked out, systems are checked out and closed back up again. Spacecraft analysis reports coming out of the back room here in Mission Control Center read some of the ones in Apollo 10 toward the end of the mission when they were down to one page. And most of the entries are all systems performance normal, systems operation normal, no change from last report, etc., etc. In the spacecraft fuel cell, the performance is normal, and the load sharing is shown within 3.2 amps. Cryogenic hydrogen and oxygen quantities now show total oxygen of 558 pounds. $279 pounds in each of the two tanks, 49 pounds of cryogenic hydrogen, 24.2 pounds in tank 1, 24.8 in tank 2. And the cryogenic system is performing normal. At 17 hours 36 minutes ground elapsed time, this is Apollo Control. This is Apollo Control, 18 hours 38 minutes ground elapsed time. Apollo 11 now some 83,644 nautical miles out from Earth, continuing to decelerate in velocity, now some 6,114 feet per second. It'll be reveille time for the crew of Apollo 11 in some 3 hours and 50 minutes. All systems still functioning normally aboard the spacecraft as the crew continues their 9-hour rest period. All measurements normal as the flight controllers here watch the systems on telemetry and the displays here in the control center. At 18 hours 39 minutes ground elapsed time, this is Apollo Control. This is Apollo Control, 19 hours 43 minutes ground elapsed time. Crew now has some 2 hours 46 minutes remaining in the scheduled sleep period. Distance outbound from Earth now 87,409 nautical miles. Apollo 11 continuing to decelerate in velocity, now traveling at 5,930 feet per second. All going well in the Apollo 11 mission. Crew sleeping apparently in deep sleep. System still performing quite well. And at 19 hours 43 minutes ground elapsed time, this is Apollo Control. This is Apollo Control, 20 hours 38 minutes ground elapsed time. 1 hour 51 minutes remaining in the crew rest period at this time. Apollo 11 on a line projected outward from Earth is directly over the southern tip of the Indian subcontinent. Distance now 90,509 nautical miles. Velocity continuing to decelerate, now 5,788 feet per second. Crew is still asleep at this time. And at 20 hours 39 minutes ground elapsed time, this is Apollo Control. This is Apollo Control, 21 hours 38 minutes ground elapsed time. Apollo 11 now being tracked by the tracking station at Madrid. Some 51 minutes remaining in the scheduled sleep period for the crew of Apollo 11. When the sleep period ends depends on the business of the day, whether the flight controllers here and the spacecraft communicator wake the crew up, or whether they wake up on their own accord and call in to begin the second day of translunar coast. Upon awakening, the flight plan calls for change of the carbon dioxide removing filters in the spacecraft cabin. A report on the differential pressure between the lunar module and the command module. Update from the ground on consumables remaining. They will remain in the passive thermal control mode through the hour-long eat period that follows the wake-up. After their breakfast meal, the flight plan calls for some navigation exercises using the sextant and the Program 23 computations of the onboard computer. These are star and Earth horizon sightings. Presently, Apollo 11 is some 93,885 nautical miles out from Earth. Velocity now 5,638 feet per second. At 21 hours 40 minutes ground elapsed time, this is Apollo Control. This is Apollo Control at 22 hours 49 minutes ground elapsed time. Crew has been awake for some time, according to the surgeon. Spacecraft communicator here in Mission Control with the green team, Bruce McCandless, is standing by to make a call to the crew. He's in the process of taking over from Ron Evans. Flight Director Cliff Charlesworth has asked that he make a call to the crew. We're standing by for this call momentarily.
Apollo 11, Apollo 11. This is Houston, over.
Morning, Houston. Apollo 11.
Roger, Apollo 11. Good morning. When you're ready to copy 11, I got a couple of small flight plan updates and your consumables update and the morning news, I guess. Over.
Apollo 11.
Go ahead, 11.
Roger, standing by for your update, over.
Okay, 11, this is Houston at time approximately 22:30 in the flight plan, in your post-sleep checklist, and in all other post-sleep checklists. We'd like you to delete the statement that says Auto RCS Jet Select 16 to on. And what we're doing here is picking this up in the procedure for exiting PTC that's in your CSM checklist. And in the CSM checklist on page Foxtrot 9-8, if you want to turn to that, we'd like to change the order of the steps in that, over.
Am I? Okay, page F 9-8, go ahead.
Okay, right now it reads to exit GNN PTC, then you've got a pen and ink change. It says Auto RCS Select 12, main A and B, and you come down to the printed step 1. We'd like to take and move the Auto RCS Select 12, main A and B down to be the second step. So the procedure would read Step 1, manual attitude 3, Excel command. Step 2, Auto RCS Select 12, main A, B. Step 3 would be verified DAP load, and so on, over.
Roger, I copy. Is that Auto RCS Select 12, main A, main B to be the...
Roger, should be the second step in that procedure. At time 22:40, or when you get to it, we'd like to commence a charge on battery A. And at time 24:10, we have an updated attitude for your P52 and optics calibration, over.
Okay, 24:10, go ahead.
Roger, P52 and optics calibration attitude. Roll 330.5. Pitch 086.3. Yaw 000.0. The nominal attitude it's pen and inked in for the P23 is still good. At time 25:30 approximately, after you complete P23, we're requesting a wastewater dump down to the nominal 25%, over. is Houston. Did you copy the attitudes and the wastewater dump? Over. This is Houston. We're not reading you at the present time. You're way down in the noise level. Stand by, please. 11, this is Houston. We're not reading you at the present time. You're way down in the noise level. Stand by, please. Apollo 11, this is Houston. How do you read? Over.
Roger, Houston. Apollo 11, loud and clear. How me?
Okay, beautiful. Did you copy the attitudes for the P-52 and the wastewater dump? Over.
Right, okay. We note the battery charge as soon as we get around to it. And the attitude for the P-52 optic cow, roll 330.5, pitch 086.3, and yaw all zeros. The attitude for the P-23, as in the flight plan, is okay. And I copy your battery charge. Crew status report as follows. Fleet CDR 7, CMP 7, LMP 5.5. And we've completed the post-fleet checklist. Standing by for a consumable update. Over.
Roger. We're requesting a wastewater dump at GET 2530 down to the nominal 25%. And there we go with the consumables update. At GET of 22 hours, RCS total is minus 3.5%. Alpha minus 3.5%. Bravo minus 1.5%. Charlie minus 5.0%. Minus 4.0%. H2 minus 2 pounds. O2 minus 4 pounds. Over.
Okay, stand by. All right, copy those consumables, and I'll read you back our RCS quantities. Got 86% in Alpha, 87 in Bravo, 88 in Charlie, and 90 in Delta. Over.
Roger, a copy. And did you copy the wastewater request?
Roger, wastewater, and we got the time of that, and it'll be down to 25%.
Okay.
Houston 11.
Apollo 11, this is Houston, over.
battery A, and the voltage started off a lot higher than I expected. It's just a little bit shy of 40. It looks like it's dropping down some now. This is the battery charge voltage. Seemed to me yesterday, when we were doing this on battery C, it started it out initially at a much lower battery charge voltage.
Roger, stand by a second and I'll get some reading on that.
On charging battery A now, I've got about 39.3 and about 1.5 amps. Looks like it's gradually increasing in the amp charge.
Roger, on RTM we're showing, I guess, 39.11 and the current about what you report. I think we're losing you in the noise again, 11, stand by. Apollo 11, this is Houston, over.
Houston, Apollo 11, go ahead.
Roger, 11, on your battery charging question. We feel that it's probably a difference between individual batteries, and it does seem to have gone away as sort of a startup transient here. Other factors that it might conceivably have an influence on it would be battery temperature, things of this sort. ECOM seem to feel that it's operating within the normal design limits, over.
All right, very good, thank you.
Okay. Hi, 11, this is Houston. If you're interested in the morning news, I've got a summary here from PAO, over.
Okay, we're all listening.
Okay, from Jodrell Bank, England, via AP. Britain's big Jodrell Bank radio telescope stopped receiving signals from the Soviet Union's unmanned moonshot at 5:49 EDT today, and a spokesman said that it appeared that the Luna 15 spaceship, quote, has gone beyond the moon, unquote. Another quote, we don't think it has landed, said a spokesman for Sir Bernard Lovell, director of the observatory. Washington, UPI. Vice President Spiro T. Agnew has called for putting a man on Mars by the year 2000. But Democratic leaders replied that priority must go to needs on Earth. Agnew, ranking government official at the Apollo 11 blastoff Wednesday, apparently was speaking for himself and not necessarily the Nixon administration when he said, "We should, in my judgment, put a man on Mars by the end of this century." Laredo, Texas, AP. Immigration officials in Nuevo Laredo announced Wednesday that hippies will be refused tourist cards to enter Mexico unless they take a bath and get haircuts. Gilberto Cazares, chief of Mexican immigration in Nuevo Laredo, said authorities in Mexico City, Acapulco, and other popular tourist spots have registered complaints about the hippies by United Press International. Initial reaction to President Nixon's granting of a holiday Monday to federal employees so that they could observe a national day of participation in the Apollo 11 moon landing mission mostly was one of surprise. Rodney Pidner, Associated Press, London, AP. Europe is moonstruck by the Apollo 11 mission. Newspapers throughout the continent fill their pages with pictures of the Saturn V rocket blasting off to forge Earth's first link with its natural satellite. And headline writers tax their imaginations for words to hail the feat. Quote, "The greatest adventure in the history of humanity has started," declared the French newspaper Le Figaro. which devoted 4 pages to reports from Cape Kennedy and diagrams of the mission. The tabloid Paris Jour proclaimed, "The whole world tells them bravo." The communist daily La Humanité led with a launch picture and devoted its entire back page to an enthusiastic moon report describing the countdown and launch, the astronauts' wives and families, and backgrounding lunar activities. Hempstead, New York. Joe Namath officially reported to the New York Jets training camp at Hofstra University Wednesday following a closed-door meeting with his teammates over his differences with Pro Football Commissioner Peter Roselli. London, UPI. The House of Lords was assured Wednesday that a midget American submarine would not, quote, damage or assault, unquote, the Loch Ness Monster. Lord Milman said he wanted to be sure anyone operating a submarine in the loch, quote, would not subject any creatures that might inhabit it to damage or assault, unquote. He asked if the submarine's plan to take a tissue sample with a retrievable dart from any monster it finds can be done without damage and disturbance. He was told it was impossible to say if the 1876 Cruelty to Animals Act would be violated unless and until the monster was found. Over.
Roger, thank you, Bruce. Very interesting. And that number 2 item, we all got haircuts before we left, and we hope to get a chance to see before we return home.
Roger. And I understand he was down there and really enjoyed watching the launch. We all think it's pretty magnificent, and you all are doing a great job up there.
This is Apollo Control at 23 hours, 22 minutes. Apollo 11's distance from Earth is 99,308 nautical miles. Velocity, 5,411 feet per second. Spacecraft weight, 96,361 pounds. A flight dynamics officer reports that in terms of distance, Apollo 11 will reach the halfway mark at 25 hours, 0 minutes, 53 seconds. At that time, the spacecraft will be 104,350 miles from both the Earth and the Moon. This is Apollo Control at 23 hours, 48 minutes. Capcom Bruce McCandless is ready to put in a call to the crew momentarily. Apollo 11's distance now is 100,685 nautical miles. Velocity 5,356 feet per second.
Apollo 11, this is Houston, over.
Roger, go ahead, Houston.
Roger. Mike, we've got some comments on the performance of P-23 for today, if you got a minute to talk.
He's all ears.
Yeah, go ahead.
Okay. For today, we'd like you on P23 to make a trunnion bias determination prior to P23 sightings as called out in the procedures, and also one afterwards. Our intent here is to check out the possibility that some sort of thermal effects may be giving you errors in the angular readout in the section. The bias that you get beforehand should be incorporated, that is, to proceed on noun 87 after you get 2 consecutive measurements equal to within 0.003 degrees, and of course move the trunnion off a couple of degrees between the measurements. The Earth should be a lot smaller in your field of view today, and I'm sure you're a lot more qualified to tell us about that than we are. But to ensure that you're getting a good angle measurement between the star and the Earth horizon, the section M line, which is the line that runs through the 2 hash marks and is perpendicular to the R line, should be parallel to the Earth's horizon at the substellar point. And then the actual superimposition of the star upon the horizon can be made any point in the field of view of the sextant above, below, or on the M line. We recommend the marks be made as rapidly as possible after the auto maneuver. If you feel that the amount of time between the auto maneuver and the time you get ready to mark is excessive, or that you don't like that auto maneuver attitude when you get ready to mark, of course you can use a verb 94, that's verb 94, to get you back to the flashing 51 position to redo the auto maneuver. Over.
Well, Roger. Stand by one. We're going to stop PTC here, and then we'll talk about this between things.
Okay.
Apollo 11 is now going out of the passive thermal control mode, in which it was slowly rotating to maintain thermal balance. It's getting set up for the P23 activities. That's the mid-course navigation. Capcom Bruce McCandless is passing up some changes in the procedures for this navigational operation.
Houston, Apollo 11.
Go ahead, 11.
Okay, we're stopping PTC now and maneuvering to our P52 and optics cal attitude. In regard to the P23, what I was trying to tell you yesterday was about that. The M line is not anywhere parallel to the horizon at the roll, pitch, and yaw, which you give me to go to for the substellar point. And I was trying to maneuver off to get it parallel to the horizon when y'all said that was not necessary.
Roger, 11. I guess in keeping the cups of coffee score, why, you get that one.
Well, okay, well, this morning let's just see how close it comes to being parallel to the M line. Before we start marking the first time, it appeared that the computation of those 3 angles was somewhat off, and that I was wasting a lot of gas by going to those 3 angles and then having to make large attitude changes after that to get the M line parallel, and in some cases it appeared to be just an excessive attitude required, and you all said it wasn't needed, so I was marking in some cases with the M line not parallel. I thought perhaps you had some processor for computing that offset and
making sense out of that data, but as far as I know, we've got to have the M line parallel to the horizon.
Roger, 11. We don't have that capability. We do require that the M line be parallel to the horizon in order to get a good mark. We feel that possibly the state vector information that you were using for your maneuver basis yesterday may have needed to be updated a little, and if you'll stand by a second, we'll give you an evaluation of what we feel you'll get today by the auto maneuver.
Okay. Houston, Apollo 11, over.
Go ahead, 11.
Roger, I'm getting ready to do an O2 fuel cell purge. Do you have any particulars on this? And I assume you want these one at a time, or can I triple up over?
We'd like them one at a time, and stand by. I don't think we have any sequence. You can do them in any order you want.
Okay.
And we're watching you on TM down here.
We wanted to.
Houston, Apollo 11. You want to look at these now 93s before I proceed on them?
Yes, please. Stand by a second.
Okay.
This is Houston. On our TM here, we're only seeing values in 2 registers. Can you read us out the contents of register 3, please?
Register 3 minus 3 balls 2-4.
Roger, minus 3 balls 2-4, and you can go ahead and proceed.
Okay, proceeding at this time. Huh?
11 Houston, after you've completed P52, we'd like to uplink you a new state vector so we start out clean on this P23. Over.
Okay. Houston, you observing the higher O2 flow on fuel cell 3? All right, Houston, Apollo 11, it's triggered the master alarm 3 times now. Well, there goes number 4. It goes up to about 1.4 and oscillates back down to about 1.1. Over.
Roger, we're showing 1.3 now on TM. Stand by a second.
And we're in Foo now for a state vector.
Roger, give us accept, please.
Roger that.
11 Houston, on your O2 flow fuel cell 3. Apparently it was flowing a little higher than the other 2 during purge, but the flow rate's acceptable. Over.
Right, understand. It seems to be flowing a little bit more and actually putting out more current than the other two also, over.
Roger, we copy. This is Houston. We've completed the uplink. The computer is yours. You can go back to block.
Okay, thank you.
Hey, 11.
Houston 11, I don't believe we were calling you right then.
Roger, out.
This is Apollo Control at 24 hours, 22 minutes into the mission. Apollo 11's distance from the Earth is 102,436 nautical miles. Velocity 5,288 feet per second.
Houston, Apollo 11.
Apollo 11, this is Houston. Go ahead.
Raj, I'm in a good attitude here to do, I have in the sections just last P-52 stars. Star 37. Is that all right for the optics calibration to save some gas, or do you want to go over to star 40?
Star 37 will be fine for the optics calibration, and we haven't noticed Verb 66 yet after our state vector.
One minute to separation.
Apollo 11, this is Houston. Your go for separation. Our system's recommendation is arm both spiral buses, over.
Okay, spiral B coming armed. My intent is to use bottle primary 1 as per the checklist, therefore I just turned day on.
Roger, we concur with the logic.
We're awaiting confirmation of separation.
This is Houston. We copy. Roger.
We confirm the separation here on the ground.
That was secondary propellant on Quad Bravo. Roger, we copy.
He's stand by.
Apollo 11, this is Houston. Radio check, over.
The Goldstone station reports a very weak signal. We believe that Mike Collins is now maneuvering the spacecraft in the transposition and docking maneuver, and the antenna patterns aren't too good at the moment. So we have a weak signal strength.
Apollo 11. This is Houston, broadcasting in the blind. Request Omni Bravo. If you read us, request Omni Bravo. Out. Apollo 11, this is Houston. How do you read?